Okay, in this video we're going to talk about how to apply truth tables to determine whether or not sentences are tautologies or not. So what's a tautology? Well, so if it is warm, it is warm. If Bob is happy, only if Bob is tall. Then Bob isn't tall, only if Bob isn't happy. If I like cookies, then I can fly, or I like cookies. If I like cookies and I can fly, then I can fly. So all of these sentences are true. They're true no matter what. They're true in any situation. And that's because of their logical structure. So for now, we're going to say that a sentence is a tautology if and only if it is true in every situation, meaning there's no, an equivalent way of putting that is that there's no situation in which it is false. So to show that a sentence is a tautology, or as we'll sometimes say, tautologically valid, we must confirm that it's true in every situation. And if we want to show that a sentence is not tautologically valid, we need to show there's at least one situation in which it's false. Note that once we've found a situation in which a sentence is false, we know it's not a tautological validity, and we don't need to worry about any other situations. Maybe it's false in other situations, maybe not, it doesn't matter. Once we found one situation in which it's not true, we know it's not a tautology. Now there are many situations. There are infinitely many possible situations, different sort of possible worlds, infinitely many possible ways the world could be, and it would take a long time to survey all of them. So, to find out whether or not something was a tautology, you might think would be a real pain. It would take forever, because you'd have to go and look at the first possible situation, and then the second possible situation, and you come back 10 years later, and you're at the next possible situation, and, well, we don't want to do that. Truth functionality is going to help us here. Remember that sentences are truth functional. That means that their truth values are fixed by the truth values of their atomic parts, their sentence letters, and nothing else. And that means that if you want to know whether or not a sentence like not P or Q is true in a given situation, all you need to do is know the truth values of the component sentence letters. And you don't need to know anything else about the situation. Is R true? Who cares? It doesn't matter. And does S matter? No. So who cares what its truth value is? You find out whether or not P is true, whether or not Q is true, and you know whether or not P or Q is true. Now remember, there are two truth values for us, true or false. And in each situation, each sentence has exactly one truth value. These are substantial assumptions, but we're assuming them. That means that in any situation, P and Q jointly have 4 possible combinations of truth values. They could both be true, they could both be false, one could be false and the other true, or the second true and the first false. And so the 4 rows of this table cover all of the possible situations. In any possible situation, no matter what, we're assuming falls onto one of those 4 rows, because either P is true or P is either true or false, and Q is either true or false. So we know you're on one of those rows. So if we want to know, is not P or Q true in every situation, it's very easy. We just look at each of those 4 combinations and find out, is not P or Q true? And if it's true on all 4 rows of the truth table, then it's true in every situation, because every situation is on one of those 4 rows. And if we find a row on which it's false, on which not P or Q is false, as indeed we can if we look at the second row,